Alright, let's adjust this and see if I can keep this stuff in the screen today. Today we're going to learn a little bit about the negative exponent rule. Here we say that positive exponents make numbers bigger, and so do negative exponents make numbers smaller? I bet they do. This is an example of what they look like, and we will move on to our next page. The rule, the negative exponent rule, looks exactly like this. A to the negative n equals 1 over a to the n. What that means is that any number, say 3 taken to a negative exponent, maybe negative 9, would equal 1 over 3 to the positive 9th power. So any number to a negative exponent is just a reciprocal of that number to a positive exponent. Okay, so let's keep that in mind as we go, and I'll show you a bunch of examples, and hopefully it'll make a lot of sense to you when the time is done. Okay, so if we follow the negative exponent rule here, this says that x to the negative 3. That means I put 1 over x to the third power. And it's as simple as that. That's how it works. This is x to the third power, which makes a number bigger. A negative exponent makes a number smaller, and I'll get into some more examples of how that looks in a second. So this is just x to the third power. That's already simplified. Alright, here we've got 2 to the negative third power, and I say that it makes that 2 smaller. Let's see what happens here. Well, that's 1 over 2 to the third power. 2 to the third power is 2 times 2 times 2, so this would equal 1 over 2 times 2 times 2. And simple math here would be 2 times 2 is 4, times 2 more is 8. And 2 to the negative third power made that 2 much smaller. It's only 1/8. 2 to the third power, of course, is 2 times 2 times 2, which is 8. And a positive exponent made that 2 much bigger. I hope that makes sense. Alright, another simple example. 3 to the negative 2 would be 1 over 3 to the second power, which would be 1 over 9. If we wanted to simplify it completely, 3 to the second power is simply 3 times 3, which equals 9. Again, it gets bigger, makes it smaller. This is used by scientists for all sorts of applications, and us mathematicians as well. Right. One more simple example like that. I've got 4 to the negative 3. That's going to be 1 over 4 to the third power. And if your instructions say to leave it in terms of the exponent, that would be it. I don't have to do 4 times 4 times 4 and get 64. But I can, of course. And it gives 1 over 64, depending on the instructions. Here it's 4 times 4, which is 16. Times 4 more is 64. So they're very similar, but again, makes it smaller, makes it much, much bigger. Y to the negative 5. This will be done as soon as I write it with a positive exponent. In a previous video I told you never leave our answers with negative exponents, so anytime we see a negative exponent, we simply move it to the other side of the fraction bar. Y to the 5th power is y to the 5th. Just want to demonstrate what that looks like. Now here is a very common mistake. This is where kids get stuff wrong. They want to take both of these terms, the coefficient and the variable, to the negative 5th power, but this could be written like this: 3 times y to the negative 5. And I think if you see it like that, you'll realize that really only the y is taken to the negative 5th power, the 3 is not. And I'll show you that a little bit more in a second. Here the 3 is not taken to the 5th power, just the y, because that's 3 times y to the 5th power. I hope that makes sense. So now I'll take the y to the negative 5, I'll apply the negative exponent rule. My 3 will still be in the numerator, but the y to the negative 5 becomes 1 over y to the 5th, so it goes down to the denominator. And it's as simple as that. So technically all of this is in the numerator of this fraction, even though it doesn't look like a fraction. Anything is over 1, so that will just bring this down to the bottom and become positive. There's no reason to move anything here, no negative exponents, that just equals exactly what it says. Okay, so let's look at that common mistake again. Make sure this 2 is not taken to the negative 4, but the x is. That's going to put this x to the 4th in a denominator. But of course the 2 stays right where it is. And this is just 2x to the fourth. I'm just hoping you see the difference between the negative exponent and the positive one. Okay, so avoid that common mistake and you'll be fine. Parentheses are relevant. Now everything inside of this parentheses, this whole quantity, is taken to the negative 2 power. So my rule for the negative exponent rule is to put a 1 over it, bring the whole term down, and make it a positive exponent. If I wanted to solve that any further, that would be 1 over 2x times 2x, which would be 1 over 4x squared. That would be completely simplified. Normally you won't see a space like this here. That's sort of a mistake on my part making it like that. But again, this whole quantity, the 2x, is taken to the second power, which is 2x times 2x, which is a lot like that there, 4x squared. Okay, so those parentheses are really, really important. Excuse my sniffling again, it's dusty back here. Okay, so looking at this one, I've got the 3x, both parts of that term are in parentheses, so the whole thing is put under a 1, and the exponent becomes positive. Always get rid of negative exponents. If I want to solve this further, I'd probably test you on it at first and have you just write that, but this would be 1 over 3x times 3x times 3x times 3x. 3 times 3 is 9, times 3 more is 27, times 3 more is 81, and x to the 1, 2, 3, 4th power. Pretty cool. Okay, I'll bet you can tell right now that this is going to be 81x to the 4th power. 3x times 3x times 3x times 3x, just like I did here on in the denominator of this one, and I get 81x to the 4th power. So just really, really master this parentheses thing. These guys were not in parentheses, so it's only the x is taken to the negative 4th power, etc. And I think I got one more thing to show you. Okay, earlier I said that anytime you have a negative exponent on a variable or on a term, it goes to the other side of the fraction bar. So technically I've got all of this in the numerator right now, but I can't have that in the numerator anymore because the rule says that's 1 over y to the 3rd power. So this stays, the x to the 2nd power stays, but the y to the negative 3 has to become positive and move. So my 2x squared stays in the numerator, my y goes to the denominator and becomes positive. And that's done. This time, it's a very similar problem, but my x term was taken to the negative 2, so my 2 stays up in the numerator, my y to the 3rd stays in the numerator, and the x to the negative 2, that has to go to the denominator and become positive. Just move the variable with the negative exponent. Very doable. I think you all can learn this. Thanks for your attention. I hope it made sense to you.